Section 5.2, we address annuities. So what is an annuity and how does this differ from our compound interest problems in the previous section? The huge difference here is that in an annuity, you're making periodic payments. So not just one lump deposit in the beginning, but you're going to continue to make payments every conversion period. So an annuity has you making payments, making multiple payments, one per conversion period. So if you're going to do it quarterly, you make a payment every quarter. If you're going to do it monthly, you make a payment every month per conversion period. So this would be like a loan or a retirement account where you're going to put in so much every month until you retire, or you're paying off a loan, you pay so much every quarter until it's paid off. So in terms of what types of annuities, we will be looking at ordinary annuities. That means that the payments are made at the end of each payment period, that are certain. They have a fixed time interval. They're simple. The payment period coincides with the interest conversion period. And finally, where the periodic payments are equal in size. You're going to pay the same amount every single conversion period, month, quarter, week, that kind of thing. There are other possibilities out there. So there's an annuity due one, which has payments made at the beginning versus the end of the payments. Perpetuity, which means a time interval that begins at a definite date but extends indefinitely. So you don't have 3 years to pay it off. A contingent annuity, which is a time interval that's not fixed in advance. A complex one where the payment period differs from the interest conversion and where the periodic payments are unequal in size. Those are complex ones. We're not going to do that. We're going to stick to the simple ones. So we have a future value formula. So the future value of an annuity. Now, all of a sudden, these are going to look a lot uglier than what they did in the previous section. So S is equal to R, and then we're going to have 1 plus little r over m to the mt minus 1 all over r over m. That definitely looks a lot more complicated than our previous sections. So we got some new letters sitting over there. So S is the amount of money that you have at the end. That's the future value. Capital R is your payment, how much you're paying each period. So this is the payment per period. Your monthly payment, your quarterly payment, your yearly payment. The rest of it's the same as before. So little r is the interest rate. M is your conversion, and T is still time. So conversion, and T is time. So let's walk one through together somewhat slowly in order to get used to how you're supposed to type things into the calculator. So this is example 1. And actually, you know what? I need more room on the board, so I'm going to erase that formula. I'll rewrite it here in just a second. But I definitely need more room. So example 1 says, find the amount of an ordinary annuity consisting of 12 monthly payments of $100 that earn interest at 5% per year compounded monthly. So in other words, you're going to put $100 into an account every month for 12 months. So R is the payment amount, which is $100, not $1,000, $100. The interest rate is 5%. So little r is 0.05. M is monthly, and T is 12 months, which makes it a year. Okay, we want to know how much is there. So again, our formula is S is equal to R. We're going to have in parentheses 1 over R, 1 plus R over M to the MT minus 1 all over R over M. So that would be equal to 100. Then we're going to have 1 plus 0.05 divided by 12 to the 12 times 1 minus 1 all over 0.05 divided by 12. Okay, so there's our formula. This one you can actually run straight through on the calculator, but some of the other ones are a little uglier to do that with. So we're going to take it in baby steps. So what I urge you to do first is go figure out what's sitting on the inside in the numerator. So this is the number I want to see. So in other words, that answer is equal to 1. So that's similar to what we were doing, so not a big deal there. So 1 plus 0.05 12 to the 12 minus 1. And if you do that, that inside part that is circled comes out to be 0.0511 618979. Now, I don't write any of this down. The only reason to write it down right now is to communicate with you in terms of the steps. So I would just leave that sitting there on my calculator. And now what I need to do is I need to take that answer and divide it by the stuff that's in the denominator in a set of parentheses. So 0.05 divided by 12. So answer divided by 0.05 divided by 12. So at this point, what I now have sitting on my calculator is 12.2788885549. So that's everything that's sitting inside the bracket. And then all that's left to do is to multiply it by the 100. So we're going to take that answer and say times 100 to get our final answer. And if we do that, we're going to get 1227.8889 actually. I need to make sure I'm rounding correctly to dollars and cents. There it is. So if you put $100 into an account every month for one full year, at the end of the year, you'll have $1,227 sitting there. So you've basically gained $27.89 in interest by doing it this way. So $100 a month for 12 months would be $1,200. You gained the $27 in interest. And that's a present value of an annuity problem. Sorry, future value of an annuity.